Hello, everyone. Thank you for standing by. As a reminder, this event is being recorded and will be archived on pumpsandsystems.com. I'm Amy Hyde, editor of Pumps and Systems Media. Welcome to How to Select the Right Pump, which pump technology is right for your food processing plant, sponsored by Uniblock Hygienic Technologies. Our presenter today is Eric Copeland. Eric Copeland is the Southeast Regional Sales Manager for Uniblock Hygienic Technologies. He has seen every type of pump used in food processing and what can go wrong. His insights stem from 29 years of experience in the food and beverage and pharmaceutical industries. You can reach Eric at ecopeland@uniblocktech.com. At this time, it is our pleasure to begin the webinar. Stay tuned after the presentation for the Q&A session. Please send your questions through the Ask Question box, and we'll get to as many of them as possible. Now I'll turn it over to Eric to begin the presentation. Eric?
Hello, everyone. Thank you for taking the time out of your schedule to attend this webinar. Hopefully you'll learn something from the webinar, and we'll go ahead and get right into it. So selecting the right pump in the food processing plants can be a challenge sometimes. There's several things you have to take into consideration when doing so. Obviously, the maintenance costs of the pump, you want to keep that to a minimum. The amount of downtime you can have in your process due to pumps, you want to keep that to a minimum as well. Obviously, you want to have efficient and short cleaning times. That also saves on chemical costs as well as time to clean the equipment, as well as water usage. There's also selecting the right pump can have an impact on the quality of your product going through the pump. And obviously you want to meet your operational requirements of efficiencies and quality on the product as well. So what could go wrong? Obviously selecting the incorrect pump for the application can cause issues. There's several different things that can happen. For example, if you take a centrifugal pump that's designed for thin liquids and you change a product or you want to run a more viscous product through there, the pump technology is not designed for that and can stop and cause problems. The product degradation is another issue you want to take in consideration. If you choose the wrong pump technology, your product quality can go down. There can be damage to particulates in your product that you may not want damage to. So you have to keep that in mind as well. Maintenance costs and maintenance issues. If you choose the incorrect pump, for example, and the pump's not designed to run dry, then you can cause damage to the pump and or degradation to your product with the wrong technology in those applications. Cleaning of the pump is very important as well. How do you plan to clean the pump? There's manually cleaning pumps, there's flushing pumps, there's clean in place of pumps. So not all technologies are equal when it comes to cleaning the pumps. And then obviously your operational goals. If you have a filling application or a pumping application where you can't have pulsations, you have to make sure you choose the technology that's appropriate to give you those types of features in the pump. So some of the things we hope you'll learn today is things how to match a pump to the right product you're pumping from a viscosity standpoint, from an abrasive standpoint, from a shear-sensitive standpoint. Which pump technologies are best suited for CIP versus COP. So obviously CIP is clean in place, COP is clean out of place. Not all pump technologies are equal when it comes to how you plan to clean the pump. If there's occasions where the pump can run dry, again, certain technologies are better at dry running than other technologies in the pump industry. So you want to choose the right one. The other thing to consider is how you're getting the product into the pump. Do you need suction capability of a pump to get the product into the pump, or is it going to be gravity fed and you don't have to have as much suction on the pump technology itself? And then the other important thing is the impact of the pump on downtime for maintenance costs as well as for cleaning. So now we've gone into a poll here. So I want to turn it back over to Amy for a minute.
Yeah, so you should all be seeing the poll on your screen now. I'll give you about 30 seconds to answer that. So it's, what is your biggest concern when selecting a new pump? If you'll please select one. And while you're doing that, just a reminder, if you have a question, please send it through the Q&A box, and we'll get to those at the end of the presentation. Like I said, we'll give everybody about 30 seconds to answer. Okay, just a couple more seconds here. It looks like most people are answering. All right. So it looks like the majority of attendees answered technology, but total cost of ownership was a close second. Eric, do you have any commentary to add to that?
No, it's good to hear that technology, because the right technology applied to the right product and application obviously is going to give you the best of all, from the downtime, the maintenance, the cleaning, and all those variables. So it's good to hear that a lot of people are focusing on the technology of the product. Obviously, cost of ownership is, as you said, a close second. That's very important as well. If you pick the right technology for the application, the cost of ownership will be ideal for your application as well, and for the technology you choose.
Sounds good. Thank you.
Okay, so now we'll continue on with the presentation. So these are some probably the most common pump technologies we see in the food industry. There's a couple others that we don't show in here that you do come across from time to time, but I think this will cover the majority of the pump applications. So we'll kind of go through each product type and go through the pros and cons of each. So first is commonly AODD pumps, which is air-operated double diaphragm pump. On the slide, you'll see at the top is what we call a typical or traditional AODD pump. A lot of times we refer to it as a figure 8. You can kind of see that the shape between the two diaphragms and the manifolding on the top and bottom looks like the number 8. Below that one, you see the Flowtronic AODD pump. It's a completely different design. We commonly call it an inside-out AODD pump. We've taken the air valve, which is traditionally in the center of the pump between the two diaphragms, and moved it to the outside of the pump, to one side of the pump. That allows the technology to hold this pump together in a different way, basically with one nut. So it's commonly referred to as the one-nut pump as well. So let's talk about AODD pump technology itself and where and why you would use that technology. I like to commonly call it one of the most forgiving pump technologies. And what we mean by that is it does have run-dry capabilities. It does have the capability to deadhead the pump, and neither of those will damage the pump for more extended periods of time compared to other technologies. It is an air-driven pump, so it also applies to what we call classified areas for explosion-proof, or you're working with volatile chemicals. Then air-driven versus electrically driven aids to that ease of use in those industries. It's much easier to configure that for an explosion-proof or ATEX type environment. Maintenance of the pumps themselves, depending on which technology you're looking at, the traditional figure 8 or the Flowtronic one-nut pump, can vary. Traditional AODDs can be very cumbersome in taking them apart, whether it's for maintenance or for cleaning, and time-consuming as well. The Flowtronic AODD pump addresses both those issues. It's easy to disassemble for maintenance as well as easy to disassemble for cleaning. Traditionally, in a figure 8 AODD, you cannot truly CIP the pump because the maximum inlet pressure on that pump is around 10 psi or 1 bar in some cases. So you can't flush the pump with a separate CIP supply pump because they would generate a pressure over that capability of the pump. On the Flowtronic pump, there are features of the pump that can be added. We call them diaphragm support plates, to allow you to feed up the inlet side of the pump on the liquid side with up to 100 psi pressure. So that allows you to use that pump and truly CIP it with a separate CIP supply pump, because it can handle the inlet pressures that go through the pump. So basically, when you're cleaning the piping in and out of the pump becomes part of that piping to be cleaned. There are some other nice things about the AODD technology. It's very versatile when it comes to product viscosity. It will pump thin liquids from water all the way to very viscous products. Think of tomato paste and peanut butter and everything in between. So we talked about it, very forgiving technology. It's also a very versatile technology when used in food applications. Now we'll move on to rotary lobe pumps. These are pumps that have two shafts, two lobes that turn. You can see in the illustration here that in this case the suction is in the bottom coming in. The product comes into the center. As the rotors turn, it pushes the product to the outsides of the pump housing and then back out through the top or the discharge side. So that's the technology. It is a gentle handling technology. It allows you to pump particulates or solids. So if you have fruits or vegetables or other large particulates that you don't want to damage going through the pump, this pump technology allows you to do that. AODD's, the previous screen, will also allow you to do that. So they also consider it a gentle handling positive displacement pump technology. So it's gentle action on the pump products. The maintenance on these pumps, traditionally these rotary lobe pumps are CIP-able designs. There are some pumps on the market that are designed for COP so that it's easier to take apart. Traditionally, these have what's called rotor bolts that hold the rotors into the pump. There are some designs that where there are no rotor bolts that allow you to remove the lobes much easier than having to take bolts or nuts that hold them in. So it's actually applicable for CIP applications as well as COP, clean out of place applications. Performance on flow rates. These pumps are typically very wide range of flow rates. They're made from very small pumps to 1/2-inch connection sizes, all the way up to 6 and 8-inch connection sizes in food tubing sizes. So because there's such a wide range of sizes, it obviously gives you a wide range of flow rates. So this technology can have a lot of benefits when it comes to the size of the pump itself. Some of the challenges in the food industry sometimes are the low-end flow rates, so the very low flow rates. These pumps in the smaller sizes can be very useful in those low flow rates. Now we'll talk a little bit about another type of pump, which is called a gear pump. We're showing here two different types. The one on the left is the external gear pump. You have two gears that turn in unison with each other per se. And then in the one on the right is an internal gear pump where you have one gear inside the outer gear. So it's referred to as internal gear. In general, it's just two different mechanical designs, but basically they have the same features and benefits. They're typically designed for what we call thin, clean liquids. Think of oils, fats, glycerin, things like that also self-lubricate. So that's typically what they're for. Most of these pumps are on the medium to small size, so from a 1/2-inch up to maybe a 2-inch typically. So you don't have a wide range like on the previous slide on the rotary lobe pumps. They are a lower cost pump technology. There's only one driving shaft in this technology. And they're very repeatable on the output of the pump, or the displacement of the pump. So a lot of times they're used for dosing pumps to feed because they're very consistent. You can actually give a fixed amount of liquid flow based on the speed of the pump. So it's very repeatable. This pump technology is traditionally a COP technology, clean out of place. The design of the pump as well as the technology, you can't CIP these pumps. From a performance standpoint, they're designed again for thin, clean liquids, but they will get higher viscosities compared to one of the other technologies we'll see in a minute, which are centrifugal pumps, which is the next slide here. So centrifugal pumps are one of the lower cost pump technologies on the market. It's typically limited for, again, mostly thin liquids. Most centrifugal pumps are good to up to about 500 centipoise. Anything over that, this technology is not typically applicable for that. They are designed for basically high flow applications, low pressures. They are not designed for applications for thinner products. Definitely, you don't want to pump solids with these. It will definitely damage any solid particulate you may have. And then their pressures are relatively low on this technology. It is a typical CIP. Matter of fact, a lot of centrifugal pumps are used as the CIP supply pump to feed the liquids to clean all your piping and other pumps and other equipment in the plants. You can take these apart for cleaning. It can be cumbersome and time consuming to do so. So traditionally, these are used in the CIP type applications. They run a couple different speeds. There's what's called low speed, which are typically 1750 RPM centrifugal pumps, and then some can also run at 3500 RPM, we'll call high speeds. Obviously, the higher the speed, the more flow you're going to get. But then also the higher speed you run these, the lower lifespan you get on the pump technology itself. So centrifugal pumps for thin, clean liquids, they don't have any suction capability at all, only pushing the product out. Another technology that's more of I would call it a newer, more up-and-coming technology in the food applications are twin screw pumps. So these pump technologies, it's one of the more expensive pump technologies. They are very high precision pieces of equipment. They are also considered a gentle handling pump technology. They will pump solids. One of the other big benefits of twin screw technology is the capability for them to pump what we call entrained air. So if you have air bubbles in your product, which would typically stall or cavitate in other pump technologies, twin screw technologies can pump that air with the product through it, typically up to around 60% entrained air. So quite a bit of entrained air this pump technology is good for. It's gentle handling. It will also, it's a low shear technology. It will pump solids without damage as well. So if you have food particulates, it can pump those with little or no damage. On the maintenance side, it can be more involved on the maintenance of taking it apart, putting it together, which also adds to the time-consuming part if you're going to COP or clean this pump out of place. So traditionally, these pumps are used for clean-in-place applications as well, because it's time-consuming to take them apart. The other big benefit of this technology is it's basically, a lot of times it's referred to as two pumps in one. It is a pump that can pump a low, thin liquid, clean liquid like CIP solutions, but then you can also pump the product, which is typically more viscous products through there, because of its speed range. These pumps are PD pump technologies, but they can run at what we call centrifugal pump speeds. So these pumps can run up to 3,600 and 4,000 RPM, depending on the brand. So that gives you a wide range of scalability. So you can pump thin liquids and run the pump at higher speeds, and you can also pump viscous products and the pump runs at lower speeds or lower RPMs. So that's the big benefit. They can pump entrained air, and they have a wide speed range. So if you have a wide range of products from a wide variety, from viscous to less viscous, this one pump can do all that. As well as it doesn't just clean itself during CIP. It has the capabilities to pump the liquid solution, CIP solutions, at the proper velocities to get the piping downstream of the pump clean as well. Twin screws also have suction capabilities too. And then the last of the 6 pump technologies commonly is a progressive cavity pump. So these pumps are also gentle handling. They can pump large particulates or solids. So they're good in that sense. It does have a rotor and a stator inside. So the biggest downfall to progressive cavity pumps is running them dry. If you have no liquid in these pumps for any short period of time, you can basically burn up your stator with your rotor because there's no lubrication between the rotor and stator that have contact between each other during the pump running. So don't want to run these pumps dry. They are a larger technology, a longer technology, we like to say. So they take up more real estate or more floor space in your plant. They also, due to the design, most of these pump technologies are not CIP-able, so you have to take them apart to clean. There are some brands that are CIP-able with some external piping connected, bypass lines to allow that technology to clean in the CIP method. They are considered also one of your higher pressure discharge pressure pumps. So you're pumping viscous liquids. That's why you're choosing a PD pump, because its pressure capabilities are higher than the other technologies. You can pump more viscous liquids at longer distances with these type pumps. So that's the other big benefit of a progressive cavity, is its high pressure capabilities. So that's kind of the 6 pump technologies. Uniblock has put together a nice little hygienic pump comparison chart that goes through these 6 technologies. It kind of gives, you know, the pros and cons of each of the different technologies. On the slide here, it's accessible on our website, uniblocktech.com. You can also, we'll have a link from this presentation, from this webinar, to be able to click this link if you're interested in this slide. So just to kind of summarize, Uniblock, the company I work for currently, we have a wide variety of hygienic pump technologies, from AODD pumps to drum unloading pumps, progressive cavity pumps for drum unloaders, centrifugal pumps for drum unloading. We also do rotary low pumps and gear pumps. You know, we've had a lot of experience and history within the food industry. The company's always been hygienic equipment and pump supplier and manufacturer. So we have extensive experience in this industry. We do have some patented designs and some of the technologies that we offer, which makes it easier for taking pumps apart, for cleaning and or for maintenance. So a wide variety of products, and we have some pump complementary products, I call them. For example, one of the items you see in this slide there is a Y strainer. So that helps protect you know, solids and foreign objects from getting into pumps that you can put in front of the pump. So just a summary there of some of the Uniblock products and expertise in the industry. So now we have another poll that we'll let Amy kind of go through with you.
Yeah, sounds good. So the poll should be appearing on your screen now. The question is, are you planning on purchasing a new pump? If so, when? And again, we'll give everybody about 30 seconds to answer that. And then we'll be ready to head into the Q&A, which is a good reminder. If you have questions, please go ahead and send those in, and we'll try to get to as many of them as possible. Also, as Eric mentioned, while everybody's answering that, we'll have emails coming to you after the presentation to give you a link to the on-demand. And within that email, you'll have a link to the chart that Eric showed. So you'll be able to access that after the presentation. All right, we'll give everybody just a couple more seconds. Right. Okay, we'll move on to the results. So it looks like most people are looking at around a year or more, but we've got 33% that are 0 to 3 months. So kind of both ends there. Eric, do you have any commentary on that before we head into the Q&A?
No, I mean, obviously their need for a pump is their need for when they have to have a pump. So we understand, you know, it's good to hear there's you know, some people that have some immediate needs. So hopefully this will be helpful to them for now. And then obviously we've got the link to the chart. So if down the road, a year plus, that they need something, they can obviously have that chart to refer back to reference if they're not sure which technology to choose for their application.
Sounds great. All right, with that, well, Eric, thank you for the great presentation. It was wonderful. Attendees, if you would like a certificate of participation for today's webinar, you can do so by clicking the View Certificate button Also, if you have questions, again, that you haven't sent over yet, we've got plenty coming into the chat, but please keep coming with questions, and we'll keep pulling those from the chat and letting Eric answer those. So let's get to our questions now. So the first one is there a downside if the pump deadheads?
So it depends on the technology. So there's most of the pump technologies, if you deadhead the pump, yes, there is a downside. PD pumps are positive displacement. If there's something deadheads, most pump technologies will keep building pressure till something gives or something breaks. So yes, the downside is something can break downstream. There's a couple technologies that's not as important, doesn't have that effect on. AODD pumps, that technology, if you deadhead those, basically whatever amount of pressure you have coming into the pump is what you'll get going out of the pump. Is what's called a 1-to-1. So on those, the maximum pressure is about 100 psi. So if you have anything downstream that can, everything else can handle 100 psi or less, then there would be no downside to that technology. Centrifugal pumps are very similar. They will only generate a limited amount of pressure, and the product will set and basically spin inside the pump and will not go anywhere. The only downside there is you can't overheat if it's an extended period of time that you're running with a deadhead on that technology.
Sounds good. All right. The next question is, how do you explain run dry to non-pump people? If a pump cannot run dry, what do you have to have in place to prevent it from happening?
So how I would describe that would be if there's no liquid in the pump. So the product, the liquid that you're transferring with the pump, if that is shut off to the pump, typically it's done accidentally or inadvertently. Someone shuts a valve on the feed side or the upstream side of the pump, we like to say. There's no liquid in the pump anymore. Then the pump continues to run. That means it's running dry with no liquid in the pump head. And so that's what the run dry is. There's no liquid in the pump. So that's how I would explain run dry.
Sounds good. This question asks, what is your recommendation for empty IBC high viscous about 35,000 CP? Hope I'm reading that right, Eric.
Yes. So IBC is a type of container, and then centipoise is 35,000 centipoise, which is a fairly viscous liquid. So there's a couple different technologies typically used for that. Depends if you're coming out of the top of your IBC or out of the bottom of the IBC. Some IBCs have an outlet valve, we like to say. But in either case, one of the more common technologies used for that is an AODD pump, an air-operated double diaphragm pump. It has suction capabilities. So you can put what we call a suction wand, if you will, into the IBC from the top. And then the AODD has suction capabilities. It will pull the product out of the IBC into the pump and obviously pump it to whatever destination you want to go to. Another pump technology for that is called a drum pump, or some people call them stick pumps. Again, you could pull from the top, you put this pump down into the top of the IBC, and then there's two technologies for that, a centrifugal or a progressive cavity. In that case of viscosity, you would need a progressive cavity style. It will pull the product into the pump and pump it out as well. If you're coming out of an outlet valve on the side of the IBC, then you could use AODD as well. You don't have to have the suction wand. You can now just have a hose connection or a fixed connection from the tank outlet valve. It will still pull the product out of the bottom of the IBC, so it still has a suction capability. So that's the couple different technologies and a couple of different ways that you could pull a viscous product out of an IBC.
Sounds good. The next question is, would you say that all of the PD pump types mentioned here have a 3A or FDA variant, or at least key food contact parts available?
I would say yes. Everything that we presented today is at a minimum what we call FDA. So all the components are Food and Drug Administration approved for food contact areas. So all the technologies are designed for that. There are some of these technologies, some manufacturers that make these technologies that are not made for FDA compatible products. So the brands and the types you saw today all are designed around FDA compliant. And in the US, we call 3A, and in Europe, EHEDGE compatible as well.
Okay, sounds good. The next question is, how do you determine the pressure you need for pumping viscous fluids?
So the way we determine the pressure, we call it friction loss calculation. So basically, from the discharge side of the pump, where do you want to transfer that product? How far are you going with that product? What line size are you pumping that through? And then at what speed do you want to transfer that product at? So if you're pumping, for example, say 20 gallons a minute, the more viscous the product is, the more pressure it takes to get it from the pump to its destination. So we do a friction loss calculation. We basically take the flow rate you want, your viscosity you have, your line size, and determine what that pressure is. So it's a calculatable item to do. And then you can look at the pump technologies and see which pump technologies can generate that type of pressure you need to go through that line or for your application. Things you can do to help improve that situation would be larger line size. So if you can, with larger line sizes, your friction loss of that viscous product are lower, which means your pressure is lower. Or the other thing you can do is lower your transfer rate. If the pressure is too high to transfer it at 50 gallons a minute, maybe you can go at 30 gallons a minute, and it will again lower the friction loss, which in turn lowers your pressure to transfer through that.
Okay, sounds good. The next question is, what is the flow rate of a load pump?
Flow rate of load pump. So as I mentioned in the presentation, there's a wide range of sizes of rotary load pumps. We go from a 1/2-inch pump all the way up to 6 or 8-inch pumps. So you can go from what we call a very low flow of less than 1 gallon per 100 revolutions, all the way up to 1,100 gallons per 100 revolutions. So wide range of flow rates depending on the brand and or the size of the rotary load pumps.
Sounds good. For the next question, they asked, how long does a gear lobe AODD pump take to clean?
So a rotary lobe pump, if it's not designed for what we call clean out of place, it's for CIP applications. It all depends on the application itself. What's your product you're pumping through? What's what we call the soilage level? How sticky is the product? So when you CIP, you're going to do that automatically. So the time it takes is typically around 30 minutes. If you were to take a pump that's designed for CIP and you want to manually clean it, take it apart, it can take much longer than that because it was, again, designed to be cleaned in place versus clean out of place. So there are some variables that you have to take into consideration from the cleaning standpoint. Is it going to be automatically cleaned, CIP'd versus COP'd? And there are some pumps out there, brands that design a pump to come apart easily to be manually cleaned very quickly as well.
Okay, sounds good. We have an attendee asking if you can repeat the friction loss calculations.
Okay, so as I said earlier, you have to basically take into consideration the distance you want to pump, the length of the piping size that you would be using to transfer on the discharge side of the pump, and the product viscosity. So those are the three main factors you have to take into consideration. Then we basically have a calculator that we can put that data into, the length, the pipe size, and the viscosity, and the flow rate you want to transfer at, and that's how we calculate the friction loss required, which in turn tells you the amount of pressure it needs on the discharge side of the pump.
Okay, sounds good. And we have a couple of attendees who have asked if they'll be able to watch playback of the presentation on demand, and you'll get an email later today that'll have a link to that. So I just wanted to go ahead and note that while we've got a couple of those questions coming in. The next question is, are you aware of CIP standards such as ASME or ISO that are required for food safety?
The The governing bodies for the food industry are typically what we call 3A and FDA, and depending on where you're at, also EHED. So those are the governing bodies that tell you what you need to have. There is no per se ASME or ISO in the food industry, but there are some guidelines that people have adopted from a application standpoint. For example, the minimum typically, if you're not sure what velocity you need, is what we call 5 feet per second. That's the velocity that's required to create enough turbulence in the piping and or the piece of equipment, a pump or valve, that will get it clean. So it creates the mechanical action. If it's less than 5 feet per second, you may not get the mechanical action to get that product clean when you do CIP. There are some industries, for example, the beverage industry, which are thinner liquids that don't soil as heavily. In some cases, you can use a little less than 5 feet per second. And in some other applications, you need more than 5 feet per second. Some people say 7.5 feet per second. So each given line size then has a calculation, what's the minimum gallons per minute or liters per minute to achieve that velocity to get that mechanical action to get things clean.
Sounds good. The next question says, how can an AODD pump only have one nut?
Okay, so as the slide showed there, it's due to the design of the pump itself. It's an inside-out design. So by taking that different take on the mechanical attachment of the pump, it has a center shaft that then can allow one nut to hold the whole pump together. So it's just in the unique design of the way it was done to be able to hold that together with one nut.
Sounds good. All right, well, everybody, that does it for the presentation today. If you have any questions and want to keep sending those in, we'll get those to Eric and the Uniblock team so that they can answer those offline. Of course, we'd like to thank Eric and the Uniblock team for today's presentation. Attendees, as I said, you'll be able to look for an email from us later today where you'll be able to access playback and presentation from the event. But please also feel free to visit pumpsandsystems.com for more on this topic and additional educational webinars. Thanks again to Eric and the Uniblock Hygienic Technologies team. And thank you to everyone for taking the time to join us today and answering those polls. I hope you all have a great day.